There's apparently a shipping expression which says when you go to sea, you either take one clock or three. Because if you have two, you're not entirely sure which one is accurate.
Good point.
If they slew. We only have one clock. The magical iPad 2, purchased just ahead of the first time we did Lightning Talks, still goes with an app that is no longer available on the App Store. And we have 16 great presentations, and we're going to run through them quickly. Do you want to say anything, Guido?
Just the fact that I think what the organizers are trying to do is give us ever larger rooms to try and dilute our stage presence. But that ain't going to work, guys. Given that we are in a bit of a hurry, because we've packed too many prezos in again this time, haven't we?
16.
16 where it should have been 15, right?
Yeah.
Yeah, all right. So, Ronald, you ready for this?
I guess so.
Bring it forth.
Okay, we started the clock? Okay. So
Asking us to start the clock.
no, I'm just questioning. Oh gosh. Oh.
Off you go.
Off I go. So this is about standards and reality. So where's the clicker? Is that the one? Okay, so this is about sort of, well, background. When you start doing a standard, sort of there is a committee that writes a standard. Committee is sort of people that just mosey in, and they are there for a while, sort of looking at the standard, coming with comments and so forth, and then they go away. And that happens all like a library. And then, of course, the next step is that someone has to implement this. And then you have to translate this text that someone has written into methods and functions. Anyone knows what this is? No? Okay, it's ENIAC. So step 3 then is, of course, when everyone has done their implementations, to actually get them to interoperate. And that's really the hard part. And that's what this talk is about. So this is what it says in the IETF, Internet Engineering Task Force, that there is nothing that becomes a standard unless you have more than one sort of interoperable implementation of the standard. Now, that poses a n-square problem, because every implementation is going to be tested against every other implementation. That's just not going to happen. So what we have been doing within OpenID Connect Foundation, and when it comes to the standard about OpenID Connect, is trying to get it to be an n problem. And we do that by creating a test tool that everyone can use. Because what it's really all about is that everyone sees the same thing, sort of when they read the standard. So everyone understands the standard in the same way. So what we did was we made this test tool, and then we had testers testing the test tool at the same time that they were testing their implementations. Do you really grasp that? So the implementers tested the test tool at the same time as they tested their implementation. It's a recursive thing. And I was at the center of this. If you like baseball, you can sort of look at this picture, because I like baseball. And all of these guys that on the playing field, they don't see the same thing. I mean, you have sort of the guy who is part of the team that is batting. Of course, he's looking at, so is this guy going to really hit so I can run? And then the defending team, sort of, is he going to bunt, or is he going to hit, or what he's going to do? And then the umpire, who is there to also decide whether it's a good or a bad pitch. And it's the same with standard. We have had, so I come to be in this translation facility, where I was between the standard and the ones implementing. So I had many calls, mostly emails, but where someone said that we've tested our implementation and we think the test tool does it wrong. And we had to go back to the text then and study it and say, well, who has the correct interpretation of the tests, of the standard? And from that, we built sort of the test tool, so that even though the test tool is based on my implementation isn't what they are testing against. They're testing against something that has been tested by 20-something implementers. But then when you do that, all are not created equal. So when you have a guy who has done sort of public domain implementation on one hand, and then there is a company like Google or Microsoft who has done sort of the implementation of the same standard. And when Google just says that, well, this thing you have in the standard, it looks good, but we will never do that because of our environment. So what do? So unfortunately, the big guy wins. So you modify the result, modify the standard. Okay, that's reality.
You're stopping?
Yes, I'm stopping.
Right, excellent. For a second there, I was afraid that you meant me by the big guy who wins. I mean, there's no winning for me here. So the next one, I feel like I should be introducing this one. Thanks for showing us, by the way, how a very level-headed treatment of 5 minutes can go. For the next one, we've got a speaker who's uploaded 45 slides, at which point Brooke went, "Are you sure you can go through these?" At which point Alex said, "I think I can," at which point Brooke said, "If not, I'll make Guido push you off the stage," at which point Alex went, and I want you all to remember this for next year, "I've prepared, I went to the gym." And I actually know he pushes more than I do, so probably I'll declare a conflict of interest. Off you go. See you.
Something. That's the next button, isn't it? Yeah, that one. All right. Okay. I'm talking about FileSender. FileSender is something that's been developed by ARNet in conjunction with HeNet and Nordinet. And the first few slides give you a context in which we're developing that. But if you want to know more, go to Jamie Sutherland's talk later in the program. So we call it Cloud Store in Australia. There's a couple of cartoons about statistics. You know, Disraeli said there are lies, damn lies, and statistics. I like this one. There's a lovely cartoon of did you know that there's more chance of your child being adopted by Angelina Jolie than being hit by a falling piano? Anyway, these are the sorts of statistics I'm going to show you in a kind of whirlwind tour, showing you this is the number of users of Cloud Store of FileSender in Australia since we started back in April 10 through to April 15. And you can see the lovely steep curve. And if you go through all of these, you get the number of users added per month, monthly total volume uploaded in terabytes, annual traffic uploaded, monthly number of uploads. They're all huge growth in usage. And you see actually there are some users, like this top 10, some who've loaded thousands of files, so they've got really good applications. Interestingly enough, 80% of the files in Australia are sent to other people within Australia. More of that later. But here's an analysis of those that went outside Australia, see USA, Canada, United Kingdom, but even places like Sao Tome and Principe, one file was transferred to there, if you know where that is. Within Australia, 68% of the files went to the same institution. So people are using FileSender not just to send to colleagues overseas or the other side of Australia, but within their own institution. Uploads by hour of day is fairly normal. We've actually introduced now a file storage facility called Cloud Store Plus, and a similar pattern of usage there. So we've currently got 4,500 users of this facility. And again, the amount of storage that's used has been growing continuously. I've then analysed, apart from the 500,000 records that Australia had, I've analysed also the records from a few other countries, and you can probably work out which those are. If not, you'll find out pretty soon. Belgium, similar pattern of usage, huge uptake, lots of uploads, mostly increasing. A few dips around July, because Europe seems to go to sleep in July. Same pattern for other countries. Total of 17 terabytes have been uploaded. Ireland, again, very steep growth. They started also about the same time as we did, back in April 10. There, the total files uploaded, the volume of the uploads by month. Norway, again, very steep curve, so I hope you're getting the impression that these statistics are worth looking at in more detail, and of course the slides will be available. This is a particularly interesting analysis, but I won't dwell on it. You can have a look at it online if you want to go and have a look at the slides. But you'll notice down the bottom here, the users as a percent of researchers. So to what extent have we penetrated the number of researchers with this tool, FileSender? And you'll see 37% in Australia, 16% in Belgium, 85.7% in Ireland. 85% of the researchers in Ireland are using FileSender, according to these stats. So perhaps there's an anomaly there, we'll try and find out. 39% in Norway. So very interesting analyses there. Looking at the international comparisons, you'll see that, as I said, 80% of Australian files go within Australia. Understandably, in Europe, there tends to be more international activity. Uploads per user, average upload file size, number of compressed files. So some people are better with compressed files than Australia is. Users as a percent of public sector, as I said, they're 86%. A lot of things we can conclude from this, so understanding what are the needs of researchers, and I won't go into these in any detail, but there is this chart which has been produced that shows numbers of researchers and how you reach them. There's that big gap between the very few early adopters and the rest, and we think we've actually got across that gap and have now reached the majority of researchers. Thank you very much.
It's a rather good outcome. Next speaker, you ready? So yes, there is a back button.
Which is forward.
I'm pretty sure that one is forward. If it isn't, I'll grant you 10 seconds.
Okay. Maybe not.
It isn't. 10 seconds.
So with the growing adoption of cloud services that we're all painfully aware of, terms of service and privacy policies are becoming increasingly important. So TOSBAC 2 is a joint project of the Internet Society and the Electronic Frontier Foundation. It's an extension of an earlier project with a group called Terms of Service Didn't Read, TOSDR. The key issue here is that monetization of user data is the key to the business model of many service providers. We're trying to help users understand that the bargain they're making when they're buying something isn't free. What they're paying for is their personal data, which can be used for marketing and other purposes. The service providers could do a much better job of informing users how their data is being used for reasons left to your own imagination. They're not doing that. Terms of service and privacy policies are dense, difficult to understand, and non-negotiable. Users, as we all know, have become conditioned to not reading them, just clicking agree to get to the services they're seeking. They just view them as unnecessary friction. And they're intended to protect one party to the transaction, which is definitely not the users. So the goal of this project is to provide a historical archive and support analysis by interested parties, for example, researchers, contracts officers, and policymakers. In 2014, the Internet Society engaged a developer to improve the system in a variety of meaningful ways, one of which was internally to make it more stable, externally to add significant user and administrative capabilities, and most importantly, perhaps, to develop an API to support further utilization of the archive. We also developed a web-based TOS viewer. It's a web-based front end which enables a user to browse the documents stored in the system and evaluate changes over time, utilizing a policy history calendar slider to select 2 snapshots for comparison. It also has support for authorized users to provide commentary to note changes as significant or not and why. The feedback we've received on this has been very positive from several constituencies, one of which is university or organizational contracts officers who in many cases have been doing this ad hoc on their own, collecting them. They're one of the few communities that actually read these things. The other is policy and researchers. So for next steps, work is underway right now to find a production long-term home for the service, and you'll hear more about that. I'm here all week and I'm happy to talk to anybody about that. Here is a screenshot of the service. You'll see it's similar to Word's track changes, and you'll see the gray bar at the top. It's kind of hard to see, but there are red lines that denote the snapshots, the dates. You can move that around to select 2 dates for comparison, and you'll see what has changed. There is the ability to provide commentary from somebody that has been designated as expert in the field to be able to note something as significant or not. In many cases, the changes are something as simple as formatting that don't mean anything. And that's it. I'm here all week. Thank you. There's a URL.
Wow.
Shocking.
Someone who keeps to time.
Yeah, that's superfluous, actually.
Let's burn some time before we have our next person up, Nicholas from the RIPE NCC. Opening reception tonight, 8 o'clock. It's on the pier, so apparently you can get outside this building towards the water rather than the road, and that will be where you'll be drinking. Apparently, you need your badges, but you're wearing them already, so that's good. Nicholas. This one is forward.
Good afternoon. I will talk about something that is old, has become hot again, and what is the relationship with how it is related to the research and education community. One of the RIPE NCC key responsibilities as a regional internet registry is to keep the RIPE registry correct, complete, and up to date. And that is important because it helps network operators make better operational decisions, and because it prevents resources from being hijacked. So what are these legacy resources that we talk about? They are IPv4 addresses and AS numbers that were distributed before the current system of distribution by the RIRs, meaning before the existence of the RIPE NCC, APNIC, LACNIC, and so on. All these years, they have been kept outside any relationship between their holders and the RIPE NCC. And the issue that we are facing today is that we have a RIPE registry that when it comes to legacy resources, it does not reflect the reality. So where do you come in? Why are legacy resources so much related to the research and education community? Well, because academic and research institutions were among the pioneers of internet in our region. Universities were being assigned IPv4 addresses and AS numbers many years ago, well before the existence of the RIPE NCC. And it's for that reason that a big part of legacy resources reside within this community. During these years, some resources were changing hands. They're being redistributed from one organization to the other, and this process was not being properly documented. And that led, in some cases, nowadays, having legacy holders not being aware of the resources they hold. If we have a quick look at the numbers, we'll understand why we are saying that legacy resources, a big part of them reside within this community. 63% of the total of legacy AS numbers, 46% of the total of legacy IPv4 were assigned to organizations of the research and education community. Now, about a year ago, the RIPE community accepted a policy proposal that establishes the principles to be applied in offering and implementing registry services for legacy holders. There are 5 options available that legacy holders can choose from. Some of them imply a relationship with the RIPE NCC, and some of them don't. And we will not encourage you to go for any option over the others. We will only encourage you to go for one thing, to keep your data current. It's important. And it's getting more and more important as IPv4 addresses become more scarce. They become more valuable, they become more vulnerable, and hijacking of IPv4 space is becoming a rising trend that we see happening more and more every day. The RIPE NCC had to investigate approximately 250 resources within 2014 alone. And hijackers nowadays, they use sophisticated methods. They are faking identity papers, registration papers, they are faking domains, they are faking entire websites. So what can you do about it? Keep your data in the RIPE database current and up to date. If you are transferring resources away or if you are acquiring resources, make sure that you are speaking with a legitimate representative of that organization. And if you have problems, if you have issues, if you need assistance in updating your registration data, get in touch with us because we would like to help. And if you have any questions, I will be around this week. We can sit together. I will be happy to meet any of you and address any problems or issues you might have. And you can always email us at legacy@ripe.net. Thank you very much.
Extremely well done again. Gives me 20 seconds to ask. Assuming people are following the Twitter stream here, has my mother commented on my dress sense yet? Because I'm actually wearing the belt she gave me.
Apparently all of my colleagues have commented on my hair.
It does look rather good.
And see? I told you! It's good hair!
I'm just hanging out for a compliment.
Yeah, well, of course.
Let's just go. Next speaker.
I usually only comment on the hair on your back though, Guido. Right? It's a fine pelt. Anyway, next. Oh. That reminds us, we have a social code of conduct policy introduced to this year's... Yes, the speaker.
Tell me how to switch it here.
This button here. No. This one is the next. Yes.
Okay.
Wonderful.
Oof. Okay, my name is Gloria Boignin. I'm sorry. My name is Gloria Boignin, and I'm from GAR, the Italian NRN, and I will talk about a study on performance and possible limitation about a coherent high wavelength transported by a DCM-based optical network. Why we want to test this is easy to explain. In our network infrastructure are made by two different platforms. One in the north is a traditional one. The client are 1 giga and 10 gigabit Ethernet. The transport is made by the lambda 10 gigabit per second and 14 gigabit per second coherent. And the infrastructure is equipped by module dispersion compensated. Instead, in the south, we don't have this kind of module. The platform is more innovative, is Infinera DTNX, the same that we have in Giant, and the client are up to 100 giga Ethernet, and the transport is made by coherent super channel 500 gigabit per second. Okay, what we want to achieve? We want that from the south, alien wavelength invade the central node infrastructure and to bring them not the democracy, but the 10 giga Ethernet opportunity. And this will probably make a smooth migration between the two infrastructure. Where we will do the test in our operational optical network, in particular between Naples and Rome, and then from Rome to Bari. It's almost 1,000 kilometers. If we succeed to do this, probably we can reach Bologna and then Milan, where we have the POP with Giant, and we will make almost all the core backbone. What we plan to study, the performance of coherent optical superchannel wavelength, and we plan to check this metrics and to see the performance. But we want also to see the behavior of native lambda that goes in the same line with the coherent wavelength. Okay, more detail on what we do. In Naples and in Rome, we will have both nodes, the one of the traditional infrastructure, and we have half of dozen lambda going through this infrastructure. And we want to inject the coherent signal made by the Infinera DTNX on the same line. The super channel are made by 10 carrier that form a sort of comb, like you can see there. And in the hole, you will have the native lambdas, and both signal will be injected in the amplifier chain. And we have the management system that check for both the platform that check if everything is okay in different points of the network. I have to skip this when this will be done at the end now until the end of the year, and then if aliens are nice and friendly, then we will have the opportunity to make a smooth migration between the two platforms, and we have plenty of other ideas, cross-border fiber, metrology, etc. If we find the aliens are manageable but tricky, then we have a mission, define a strict operational procedure to have to do with that. If they are entirely dangerous, okay, it's what to go.
Thank you. Come on. Who's the next speaker?
Luke.
Of course he is.
Rather a regular, I think, for the Lightning Talk sessions. Are you not? Have you been here before?
Maybe.
It's not your first time on stage. Not your first rodeo.
But we're on time now, that's a good thing.
Yeah, let's just banter about it a bit.
Yeah.
Yeah, no.
Now he's got great hair. This is what I'm looking for. Colleagues, this is what I'm going for. I'm going to have to go through a Billy Ray Cyrus mullet phase for a while, but then I'm going to have this.
Stage, just seriously. Okay, thanks for that. Hi everybody, I'm Luke from the University of Twente in the Netherlands. And I want to see how we are doing security-wise in our IPv6 internet. Now, I won't be boring you with graphs about IPv6 adoption because, well, fortunately, they are increasing, slowly but surely. I do want to point out maybe something else that's really obvious. We see that deploying IPv6 is hard enough to get it functional. So security tends to come second if people are actually paying attention to security at all. Now, if people pay attention to security, there is still a lot of stuff that can go wrong. People spend lots of money on their v4 approaches and solutions, and they think that they can reuse them simply in a v6 network, right? And these assumptions may hold on, let's say, stuff, threats, attacks on the application layer, right? But there is so much more in IPv6, right? Everybody in this room knows that v6 is more than IPv4 with just a bunch of more addresses. No, there's much more going on. You can think of ICMP6, the role of ICMP6 within IPv6 now, and transitional technologies like 624 or Teredo. Another thing that plays a role here is that people might not be aware that they are actually doing v6 on their networks. You can think of end users where the ISP enabled IPv6 on their connection, but they have no clue what IPv4 or IPv6 is, and they have not taken any precautions, right? So they might end up in a botnet over v6, be not aware of it, their ISP might be not aware of it, and we have a whole lot of trouble. Another thing here is that you might be doing IPv6 locally in your local networks without being aware of it, right? And that comes with its own spectrum of problems. And then there is the category of people that are aware that they do v6 and they think they have taken all the precautions. When we assess IDSs and tools that stand for security, the feature set on IPv6 is always more limited than things they support in v4. So if you have the perfect IPv6 solution, then I would love to hear about it. Not the first one who is looking at security in IPv6. There's a lot of work that has been done. If you search in the literature, you find loads and loads of papers, but actual measurements, large-scale measurements, they have not really been performed. You can find some stuff on a handful of dark nets, which I think is not really a good approach here, because you cannot simply scan the IPv6 address range. So what's the chance of somebody ending up in your dark net? It's purely coincidental, right? So the results that were yielded from those experiments, they do not tell us much. So I think it's time that we do some measurements in networks that have been IPv6 enabled for years. And typically that's campus networks, university networks, and NRENs, right? So that's most of you guys. So we've created a vantage point, software-based, which is flow-based and therefore scalable, right? So we check what's going on the network, on v6, purely based on flow information, be it NetFlow v5, v9, or IPv6. Everything runs in a Docker container, so it's very easily deployable. And last but not least, it doesn't send out data, right? Well, it shouldn't send out data, but it does save some data. It saves what kind of attacks it sees, right? Because that's what I want to know. So you run my Vantage Point software, and you tell me what attacks you see. I give you detection on v6 on what's going on your network. And on top of that, I also, because it's flow-based, give you detection on what comes out of your network and what is actually attacking and threatening the internet over v6. So if you're curious on what stuff we already detected and what stuff we can detect, come to my poster. I'm here all week. Thank you.
And Luke reminds us all that we should be going down to the poster sessions in the coffee breaks. They'll be staffed in the afternoon, and hopefully you've seen a really big board that is largely empty at lunchtime, but slowly filling up as people arrive and put their posters up. So they'll be attended, and you should take the time after you've had your lunch to wander around and have a look. Next, my conflict of interest, Peter Zegedy, my colleague.
I'm not in conflict with you.
I kind of like him,
I'll be gladly pushing both of you off the stage.
Okay.
Right? Carry on.
All right, so E stands for education. So what NRENs can do for open education, the use of video in education environments is growing. This is my 5-year-old in kindergarten, previously well protected. But indeed, instead of using the legacy bookshelf in the background, they are actually watching videos on tablets. So indeed, the showing videos in classroom, that's the biggest use case, other than other use cases for using video in education. This is another example. This is a professor at the University of Utah. He did a great thing. He integrated 3 systems together that was available to him: the learning management system of the university, the student administration system, and some other online tools for notes, minutes taking. And then he compared the results with the scores that students reached at the exams, and he realized that there is no correlation between the physical attendance of the classes and the scores that they made. But obviously there's a clear correlation between the number of videos, how many times the students actually watch the videos during the classes, and how many notes they're taking on the actual scores that they got in the end. So what education needs, obviously they need tools, good tools to insert it, but I'd like to focus on 2 aspects. One is the integration with video and video content with learning management systems, and the other thing is to access the useful content. So the Géant OER initiative is about these 2 aspects. What we are doing, there are various content repositories within the community. This is at the institutional level, this is at the national level, run by NRENs or run by various universities. What we are doing, we are developing a central hub, a metadata harvesting and aggregation hub. So we go down to these repositories, we collect the information from the video content, from the data, we keep the content where they are, we don't move the content, we just aggregate the metadata and make that available on a single portal. So the future vision includes a REST API that we're going to develop so we can do the integration with those tools. Hopefully you're familiar with all these tools. And we can actually also feed back disaggregated information to the original source. So if you run a repository, you can enrich your results. We are in the pilot stage. It's been picked up by the Géant project. We are developing this further. We have 9 repositories at the moment connected to the hub. Some numbers, we are collecting more than 33,000 objects, individual videos or lecture recordings at the moment. It's growing fast, we hope. What we do, we make all this available on a single portal. So we have an OER portal. This is just a demonstrator for you, but we develop this further. And the great value here is that you can do your search. It searches through all the metadata sets, and you can basically link together the typical contents from various repositories on a single page. The other point was integration. So integration is important. We're working on some integration aspects with the leading learning management tools. We're focusing on Moodle and some Moodle integration. So if your university or your customers using Moodle, or you provide a Moodle development platform, this is very useful. We also think about Kaltura. They are presenting downstairs, so you can talk to them as well. If you are in Géant, you must be familiar with this platform, the well-known SharePoint thing is. So it's just an example that Kaltura has a plugin to SharePoint. So if we make the Kaltura integration, it means that all your NREN videos and repository videos can be immediately available on these platforms if you provide services on top of that. So I have 3 messages for you just to close. So if you are an educator on a professor, the main question for you, are you ready to publish your content with an open license? That's the key issue for open education. You should not be afraid of empty classes or classrooms because, as you said, there's no correlation between the physical attendance and the scores that the students make, but the videos and the notes, they are important. If you are running a repository, are you ready to connect to the Géant OER or join this initiative? I'll invite you to do so. As I said in the pilot phase, we already have 9 repositories. Some of them are NREN run repositories, some of them are big institutional repositories. We also do harvesting via iTunes U RSS from Stanford. So we got all the Stanford videos that Stanford makes available on iTunes U, for instance. We're working on the integration of YouTube channels and so on. So we are trying to be as broad and as open as possible in that, and this is a general message to all of you. Are you ready for open education? Open education is the key for future.
Fabulous. I can't believe you guys are all doing it on time. I never managed to. The next presentation is probably the first one where I'm actually going to shout out the name of the prezzo, simply because it's why. And I really wonder, I really do wonder why. Do you mind coming up to the stage? That's good. Somebody's actually taking her time to get up the stage. That's some presence. I feel sort of radiated off the stage.
Yes, sorry.
Damn.
So
Off you
here's
go.
Okay, thank you. Good afternoon. I am Lauren Rotman, the group lead for ESNet Science Engagement Team. ESNet runs the national network for the U.S. Department of Energy. And actually, today's talk had the title of Why. But given that, so I need to actually tell you that this was a talk submitted by my boss, Greg Bell, who could not be here today, and since he is several thousand miles away, I'm going to throw him under the bus in case this talk does not go very well. He certainly can't blame me from Berkeley, California. He was inspired by a book by Steve Sinek, who writes about how we should be asking more about why instead of what and how, in terms of how we perform our jobs, how to become better leaders, how to become better pioneers, and that's kind of the message that he wanted to get across. I think in our community, and particularly the conferences that I go to and the folks that I work with, we spend a lot of time on the how. I asked the ESNet staff, who are mainly engineers, to send me their favorite network diagrams, and I got literally like 150 of them. And they're amazing. I mean, this is like, the LHC1 overlay network. I can't even read part of it. It's amazing though. It's entirely complicated, but incredibly necessary to support the networking that needs to happen at the LHC and for the LHC community. This is another diagram that was sent. I think this was for a supercomputing demo a few years ago. Again, beautiful. Very focused on how we're going to be using specific demos. And this was an SC13, so we were in Denver, I believe. Another really nice network diagram from someone on staff. Again, complex, beautiful, very useful for the engineering community. This one's my favorite because there's Nick Baraglio, one of our engineers. He likes to use dragons in his diagrams. I thought that was a nice touch. But anyway, my point here is to say that these are all very critical and useful tools for the network engineering community in terms of how we build and optimize our networks for scientists. But I think that there's still a disconnect between what the engineering community is doing and what scientists need. And I would say that we start to talk to scientists and we show them diagrams like this, and scientists be like this. They don't really understand the diagrams, they don't really understand some of the way that we talk about services, the way we talk about networks, and so we've been really focused on understanding the why, meaning what is the science that our colleagues are trying to accomplish. Science is changing, scientists are changing. It's no longer just the big, large science collaborations that are producing a lot of data. There's now very small instruments that can produce a lot of data, and incredible science is happening. This is a picture of one of the youngest supernova ever to be observed. This discovery was made just a few years ago using a combination of telescopes and networks and supercomputing resources. My team and I spent a day with a scientist at the Advanced Light Source at Berkeley Lab with a scientist that was studying pediatric brittle bone disease. These are actual bones from children that have this disease, and he runs them through these lasers and is able to do this analysis and understand a little bit more about what might be causing that disease. Another thing at the Advanced Light Source is several things in the life sciences space. This particular was an experiment in finding new ways to fight ALS, or Lou Gehrig's disease, which is a very serious disease. And within ESNet, we're really trying to embrace this idea of putting the science first, asking the why. What are we doing? Why are we building these networks? Why are we building these services? And trying to connect to the scientists on, with services and ideas that they can really take advantage of immediately to make their science better. We want to make sure that collaborations at every scale are able to take advantage of the networking resources that our community has been working so diligently to build over the last 20, 40 years. So I just ask, science engagement is a kind of a new thing in this community, and I would ask that anyone interested in, time is up, to join me and email us at engage@es.net.
That was a cracker, and having to perform some form of PowerPoint karaoke by carrying someone else's slides. In fact, Lauren only turned up half an hour before she actually spoke, so Guido and I were deciding whether we should actually attempt to give her presentation for her. Guido thought it was a very bad idea, obviously because it was Brooke's idea to begin with.
And I think she actually handled it rather well, I would say, yeah. Right? Next up, Kuba, who is a fairly aggressive guy, talks about smashing boxes all the time.
Okay.
Ham it up.
So CERN starts with CERN, so let's start there. So innovation has always been part of CERN's culture. When LHC was designed some 25 years ago, the technologies that were required to build it didn't exist, and it took many years to innovate and push technologies beyond the frontiers in order to achieve it. And actually, LHC is about high-energy physics, and high-energy physics is ultimately about understanding the evolution of the universe and ultimately understanding about the origins of this beautiful physical world around us here. So, but even the most impressive scientific discoveries wouldn't be possible without two key points: sharing of knowledge and accessing a lot of data. So at CERN, we constantly try to research new ways of storing, managing, and sharing data. So when World Wide Web was created at CERN some 25 years ago, it was indeed created as a platform for sharing knowledge between the scientists. And these days we handle lots of petabytes of data. We do it in a system which is called EOS. It handles 140 petabytes of LHC data, and it allows us to manage transparently not only the huge data repositories, but also to do so across file servers which are spread across 2 geographically distributed computing centers. So what we've done with CERNbox is to add modern cloud storage interface, which are perfectly fused with this petabyte storage underneath. And actually, our users and researchers have many different ways of accessing the storage. And the key feature of the system is that all of these ways are very robust and always stay in perfect sync and are very consistent because we handle ACL consistency and the namespace in the underlying common storage layer. So let's have a look at some of the possible access points to the storage. So the storage may be mounted as a file system. This is very important for servers running in a computing center which do not have graphical interfaces, but which do a lot of bad job processing. And here you have an example of all the petabytes available mounted as a Linux file system. But in the desktop environment, it's possible to export as a Windows network drive or a Finder shared drive exactly the same storage and get access to your data from your desktop. Actually, many of the data files stored in CERNbox have internal structure. And we offer optimized protocols to handle access to this data, so analysis frameworks and applications can do data analysis extremely efficiently on this platform. For offline data access, we have a synchronization layer with eventual consistency. Here we have an example of a sync client running on my desktop and synchronizing the files. Sharing is very easy. Users can very easily create shares and list what has been shared by them and with them. Also, files are accessible through mobile devices and through the web browsers. So all this allows us to think about creating innovative workflows for scientific computing. So for example, when a researcher is capable to easily share the results of his analysis with his colleagues and synchronize it to his laptop for offline processing. These ideas resonate very well in our community. So we have a new service, but the usage is skyrocketing. So we provide very, very reliable and robust service, and this uptime number also includes the scheduled maintenance periods. So in order to manage the system at this level, you need to do quite a good quality assurance job. So we've created some tools to do the job. We are able to test very complex synchronization scenarios in order to avoid regressions. We're testing protocols and APIs, and we are able to detect very, very rare error conditions. So we love sharing knowledge and experience. So I would like to invite you to the follow-up of a very successful workshop on cloud services and file synchronization and sharing that we held last year at CERN. This time it will be held in ETH Zurich in January next year. Thank you.
Well done, thank you. You know how to handle that thing. Thank you so much. We're going well for time. Andrew, you ready?
As I got, yeah.
Take it away. I think it's, yeah, that's how it works.
Okay. So we spend a lot of time building these complicated SDN software-defined networks. Our users can get slices on these networks and they can do wonderful things, but for some strange reason, they still care about performance. It is possible for a network slice to exhibit different performance characteristics than the network slice that you happen to be using to test the physical infrastructure, be it through software bugs or how a slice is configured, possibly inadvertently or whatnot. And so is it possible that to create a sliceable persona server that will allow us to scalably test any given user slice? The answer is a resounding maybe. My work is pretty early on. and I'll go, but the idea is we take Docker, Docker, you run processes and containers on a server to virtualize them a little bit. One of the advantages of using Docker versus a traditional VM, especially where Persona is concerned, is that you still have access to the hardware clock, which is very important when you're trying to measure latency across the network. Persona Docker is kind of done. In fact, I use the ESNet Persona Docker container that's available on GitHub in my testing. Open vSwitch is a software switch. We can run networking on a host. It has wonderful integration with Docker, but if we put these three things together, maybe we can have the flexibility we need to do the testing that I'm talking about. But step one, how does Persona perform in this environment? So I made a little test lab. Unfortunately, I didn't have access to a very good hardware. My test host is an old Dell R610. My other host is a low-end Persona host from a low-cost Persona project. They're connected together 10 gig. I essentially run 3 sets of tests. I run vanilla Persona box to box, so CentOS 6 net install. I convert the test host to Docker with a container, and then the third test is I throw Open vSwitch on the front in a relatively simple network setup with just a VLAN through it to get the packets from the external interface through the bridge. The first test I run is OAMP. I know this looks bad up here. It's actually not that bad. The results down here are relatively reassuring. So the blue and red lines are kind of behind. They have the same relative characteristics, so the Open vSwitch characteristics to the vanilla Persona. This outlier, I think, was due to an NTP condition I didn't realize on the host. OAMP gives you clock errors as well as send and receive times. If you subtract the send and receive times, we can get some more granular numbers than the 0.4 milliseconds isn't terribly interesting. So these are the send and receive times simply subtracted. But I do have a big clock error, so I think when I ran my Docker-only test, there was a condition I wasn't aware of. TCP, however, is a different story. I did get a poor result. The blue line with the dip, that is Open vSwitch transmitting from my test host to the other host. I really expected that to be up on the 9.9 gig line. It was not. It is not clear why. Well, it's clear why from here, because I have a lot of retransmissions. It's not clear why I have a lot of retransmissions. My CPU is doing okay. So, the base Persona, you throw in Docker, you throw in Open vSwitch. There's obviously a little step down as you add more services, but it's not clear why I got this result here. I'm thinking it might have been with my underpowered hardware. So my next step, I guess the first step is the question of, am I on the right track? And if I am, do you have any advice on my methodology? I need to get better hardware so I can overcome the doubt that it's my hardware causing the problem. There are other stumbling blocks to consider, such as if you run multiple Dockers, how do you stay within the physical bandwidth constraint? There might be others. Open vSwitch gives a lot of flexibility. What can an aggregate manager do? And thank you.
Finish the sentence, Tom.
No, I'm done.
You're done? He's done.
And remember, you can show your appreciation or give us some feedback on not only the whole session, but every speaker. If you get the Conference for Me app, you can search for Conf for Me or Conference for Me in the App Store, Google Play Store, and whatever the Windows Store is called. I don't know what it's called. Anyone has a Windows phone? Be interesting to see if that works. Anyway, you can do that. You can also log into the website and give some feedback that way. We actually do pay attention to this stuff because, as Guido and I know from being on the program committee for life, that we do actually sort of mine and look at this information to work out how to try and make TNC better for you every year. Next, we have Roderick. Please take it away.
Which one's forward?
Yep.
Right one's forward. Yep. Good afternoon. My name is Roderick Moy. I'm from the South African National Research Network, and together with our partner TNET, we comprise the South African NREN. I'm going to talk to you today about our experiences with perf sonar. We found out about perf sonar in 2012 at TNC. We tried out both flavors, the MD and PS. I won't go into the detail why now, but we settled on PS. We have 13 permanent nodes. That covers our entire backbone, as shown on that map. And we're running version 3.4, the latest. We have one node in London, and hopefully soon we'll have one in Amsterdam. It's already been shipped. There's us on the global map, just so that you know we registered at the lookup service. Most of the red dots in South Africa are ours, and one or two of others that are not a part of the same community, so we all test each other. We've added Mad Dash as well as used the mesh configurator in our deployment. That is what our Mad Dash page looks like. It's accessible at the link at the top if anybody wants to look at it. And we have the throughput and the loss and latency obviously on separate graphs, and a little map on the side that just shows how we planned the configuration of the mesh. Version 3.4 is nice graphs. That's what one of them on our network looks like for typical links. The up and down is day versus night utilization. At about 3 p.m. in the afternoon, network is the most utilized, and about 3 a.m. in the morning the least. And those two little ones where there's not much movement are over weekends. So if we see that, it's typical, and we're usually very happy. One of the interesting projects that we are involved with is the square kilometer array. That is what the first antenna looks like of the Meerkat, which is the forerunner to SKA in South Africa. The site plan is there at the bottom, and that site, the X on the top right, is the core site at Carnarvon. We have a perf sonar server deployed there. Made an interesting study for us, and so one of the TNET engineers, we found initially when we deployed that the throughput wasn't so great, so she did a whole lot of experimentation and ran parallel streams and all of that, and in the end found that there was an egress buffer limitation on one of the routers, and so we identified that, we've swapped them out, and we're looking for improvement. But with multiple flows, we could get very close to 10 gig on that link. That is what a bad graph looks like. There at the end, you can see the loss went up and down quite a lot, and there was a packet, and then eventually went to dotted lines where it just like died. Yeah, that link failed and has been repaired. So perf sonar enables us to pick up these kind of problems, and we run a managed bandwidth backbone, so we often have to escalate it to the telcos if we believe the problem's on their side, and then they fix it, and then we carry on. Perf sonar also helps us identify throughput limitations. One of the obvious ones is just increasing MTU size. You can quickly take your 1 gig transfers up to 9.5 gig just by changing MTUs. We also have insight onto our network. So as you can see in this case, we got an email to say that there's a problem on one of the links, and we've had to go over to a redundant 1 gig link, and there you can see on the perf sonar graph it dropped immediately. Stayed at 1 gig for a while until the link was restored, and then it went back up to 10. One of the unique challenges that we have in our country at the moment is that there is not enough electricity. So what happens is that from time to time demand approaches the supply threshold, and our electricity supplier has to implement what they call load shedding. That means that they turn off certain parts of the country at a time to avoid the electricity grid from collapsing. There's been plenty of jokes about it, South Africa being named the most romantic country in the world because we eat dinner by candlelight every night. Yeah, so there's examples of the warnings that you see, and basically what this now means is when we see graphs like this, which means that there's been a routing change, an increase in latency on the links, we have to pull out the load shedding schedule and check, okay, maybe there's power problems. Unfortunately, some of our sites, the UPS and generator backup doesn't always kick in or doesn't kick in time, and so then one of your pops goes down. Thank you very much. Next steps, we want to put Nagios alerts on, mobile loads, engage the community more to do their own deployments in their lands. There is my email and our website if you would like to have more information.
Thanks a bunch. I just get the feeling we've taken the challenge out of this, don't you?
Take longer if you want.
Ah, there we go. Here's the challenge now. Hi, Brian. Another one of the repeat offenders. It's good to see you back. Apparently, the not only is it too easy, it's also almost enjoyable. Apparently, if you keep on coming back. This is entirely wrong, Brooke. We need to do something about this. To the stage and off with you.
No comments about my hair, no? Right, so yes, HENet Accelerate Connectivity Program, which is a very grand name for a very simple thing. Researchers, we all have many of them, and one of the big things is trying to get more in touch with them and really do more of their services. So apparently they do lots and lots of stuff, most of which just seems to be science. I'm an historian, what would I know? But they do lots of things, and we're really, as an NREN, trying to reach out to them, figure out what those particular needs are, what the things that the research community really wants. So the idea of the Accelerate Connectivity Program is to connect between academic and industry researchers. So it's to leverage the network to reach those locations at lower costs and help everybody. There's a URL there, you can look at it later. It has a lot more information that's in this talk, but it really is still very, very straightforward. You have your hyper-mega global corporation on one side, your research institute on another side, and connecting them together. So with one of these, the client applies for a connection, and we set up a point-to-point link between those two sites. It's really that straightforward. There's nothing technically strange here. It's just really the big mental leap was us saying, okay, you can do this. As I say, the AUP is still there, but it was a huge decision for us to go, okay, we're going to actually connect a commercial institution, a commercial entity. And that whole thing of always being very careful, always just research and education, nothing more than that. So extending the campus LAN into one of these giant companies, the Cisco's, EMC's, Intel's, et cetera, Ireland's a very popular place for this kind of thing, which is wonderful. More companies should come to the island, although eventually we will run out of land space. Was the big thing, and it means that we can put those connections in, we can avoid having to route all that traffic over the big bad internet, and especially one of the things we really want to avoid is having to get another connection into the campus just for this research group. So we think it's quite a useful thing. Money is always an important topic of conversation. Obviously, we can't use the Irish taxpayers' funds to fund this, because the Irish taxpayers' funds can't fund anything at this point in time. There are none. We look down the back of the sofa, we've got nothing. So the full cost of the connection has to be passed on to the client entity. Now, the assumption at that point is that they will pass it on to a research project or the large corporation or something like that. And we will take that money in purely on a cost recovery basis and obviously make no profit on it. But it's not being subsidized by us or the Irish taxpayer. What it very much isn't is any sort of attempt to provide internet connectivity to the commercial entity. It's also not an attempt for us to get in any way involved in intellectual property rights. That's complicated, requires a fleet of lawyers, and again, let's go back to that whole lack of money down the back of the sofa bit. So the IPR stuff stays with whoever it stays with. The commercial entity may not use this connection to access the internet. It is purely a link between the research institution and the commercial entity and their research site. And if Intel are connecting, for instance, their finance people can't use this connection to connect to the internet either. And importantly, none of the other services that HENet offer, whatever it is, 40-something services we offer these days, may be used. It's just about connectivity to that between those two sites. So that's it. Very straightforward. There's a URL there with a big glossy brochure on it and things like that. We think it's very important. It's a mental change for us that we're connecting people like this, but we're doing it with the equipment we've got, with the network we've got, and we're leveraging the power of our national network to hopefully further connect researchers. So yes, that's that. Very happy to talk to anyone more about it. Thank you very much.
And if you want to see more of Brian, he'll be back on Wednesday's Lightning Talks, because he's got another session there that we're going to enjoy. Oh, good. Next we have Raphael. Wonderful.
Okay, so yeah, we'll present you an authorization service for virtual organizations using SIMPA Group Manager. Well, at Renater we host VOs, lots of VOs, and those VOs want to access dedicated web resources. So the question is how to really easily grant access on those resources for the members. Well, the VOs are hosted in our SIMPA infrastructure, and on the other side, we have federated identities. The members of the VOs came from French university, for example, or via Edigain, or if they have not IDPs in their institution, they can use our guest IDP for Homeless, so that we will make use of those two infrastructure to build our service authorization, which is simple, you will see. Well, the main assets of SIMPA is that it's a really user-friendly web interface to manage group. On the same page, you can edit roles, you can add a member or add multiple members, so that you can let the administration of this page, the management of the groups, to a user who do not know anything about technology. Other assets are that SIMPA has various connectors to populate the groups. You can populate it via SQL, LDAP, SMTP, flat files, SOAP, Voot, even other SIMPA infrastructures. Plus, SIMPA natively offers 4 different roles, so that's enough to manage groups within SIMPA. Renater is in charge of developing the SIMPA project, and we have been using SIMPA since 18 years old, so that's why we know very well this software. Some statistics which lead us to choose this solution is that we have many VOs that use SIMPA as their main group manager. More than 1,600 VOs, up to 300,000 members. And we can see that our main domain for domainless, called groups.renater.fr, has an exponential growth since 15 years. Some figures with the French Federation, with the other ID. More than 200 IDPs, 600 SPs, 22,000 guest accounts activated on our IDP for guests, and plus Edigain. So let's see the workflow. The solution is quite simple. We just add in front of the SIMPA an IDP configured as an attribute authority, and we protect the web resource with an SP. So that workflow is quite usual inside a federation. The user who wants to access the resource is redirected to its IDP, it's authenticated, and then the SP gets its email to request the attribute authority. Then the attribute authority requests all the groups of the user in the SIMPA database, so that the SP gets each groups. And if one of those groups is allowed on the resource, the user can access the resource. So it's quite simple. It's all same old flow and a little SQL here. The implementation is a standard one. We use the SIMPA 6.2, which will be launched last week with a Chabolet IDP2. We expect to use the IDP-v3 this summer, configured as an attribute authority. Renater will shortly launch his new service, File Sender Premium. We'll make use of extra cutters. We will allow one group on the file sender, including various groups managed by the institution who paid for this new service to get big files. Here are some resources. You can test a demo here. You can find documentation there. Contact me during this conference or at poster session or via email. Thank you for your attention, and thanks to Lucas, who did a good job at Renater. Thank you.
That's going to be like, that's the most perfectly timed talk ever.
What are we going to do about this?
Yeah, the 3-minute talks.
Ah, here's something to do about it.
Here we go.
Oh, dear Lord. Let's just dilly-dally for a couple of minutes.
Yes. Yeah. Pause for reflection.
Indeed.
Did you fill in your feedback for the last presenter?
Good one, indeed.
No, the left. No, not that.
He's trying to zap.
You're trying to light me up, right? Okay.
All right. Let the Grim Reaper commence.
All right. So this is the most boring topic that I could come up with. Federations run off of metadata. It's the way we describe services, identity providers, everything we do when we deliver services. Now, this is an n-body simulation of the world's identity federations. The size of each ball is the square root of the size of the number of entities in the federation. So, UK Federation, InCommon, Renater, EduGain. Now, we created this thing called EduGain, and it's sort of a big ball because it's made up of the sum of some of the other parts. So, somebody up here, I didn't figure out who that was, publishes a service, drops it into EduGain, and it immediately appears in all of the other federations. All good and well, right? But what about this guy? There are a couple of these corner cases that don't really belong anywhere. They're not in any federation, but they want to be everywhere. Some of them have to be in all of the federations, right? And they have to sign federation agreements with everybody. Now, if you're like a publisher, like Elsevier, Springer, that's all good and well. But if you're the Czech atlas of pathological images or something like that, you don't have any funding, you don't have anywhere to go. So back in Vienna, we created this thing, we started to work on this thing that we used to call PEER, or we choose to call PEER. And it was in 2010, I think, Ken Klingenstein was in the room sort of formulating the problem, right? And, you know, having something deployed and ready within in 10 years in this community is probably pretty good. Right now, what we have is a running service called reap.refeds.org. It contains metadata for some of these corner cases, and it's something that you can use with your federation to bootstrap some services that probably not a lot of your users are going to care about, but the users that do care about those services are going to find it invaluable that you can provide those services to them. So right now we're working on this backlog of work in the service. We're doing a lot of JavaScript updates, a lot of UI improvements, and we're improving the workflow overall in the system. So if you want to track our ongoing development, just look at GitHub. Everything we do is open source, of course. Everything we do is published using Docker images, so you can set up your own instance of this and play with it if you want to. And if you want to look at the metadata, if you want to use it, if you want to look at the services, this is the URL to go to. I encourage you to include this into your Federation Trust set and help make some of the corner case services in the world available to a lot more users. So, did I break the record? I broke the record, okay?
I'm pretty sure you've broken 2 records. Did you make those slides in the last hour? That could be a really nice one for the next... what's going on? Am I being timed? There you go. Credit and some... before she's even started.
Yeah, I think I can make a moral claim on life's extra minute there.
Yeah? All right. Here's life's extra minute.
Just click forward. Yeah.
That's how I think it works. I haven't presented.
Okay, good afternoon, everybody. Bringing you to the last stretch home. My name is Anne Harding. I've been hanging around NRENs for a little while now. And between HEAnet, Switch, and Géant, I think I've done everything from systems administration to network engineering, project management, product management, dabble in business development, you name it, I've done it. But I'm here today with no logos from any of my affiliations to talk about one of the real strong foundations for connected communities, and that's people. Well, actually, I'm only going to talk about some people. I'd like us to do a very quick and unscientific experiment. Could all the women in the audience raise your hands? Okay, put your hands down. Could all the men in the audience who have a very common name in their language raise your hands? It's about the same. Every week I sit in a room where there are 3 women and 3 Thomases. This is what I've been calling for years the rule of Daves. At TNC, for example, the registration number of women to overall participants is about 17%. This actually really strongly matches the profile of the penetration of women into ICT. For example, in Google, there's about 17% tech. In Facebook, it's about 15% tech. Cisco goes up to about 23% tech. In Europe, about 19% of ICT sector people are there. So you can see we're roughly average. But why is there such a poor representation of women in ICT when we make pretty much 50% of the registration in universities annually? Well, you're going to hear an excellent presentation on Wednesday about subconscious bias, but I'm just going to focus on a couple of quick areas. The first one is that subconscious bias is easier to grow than to shrink. Any natural human mistake that a woman might make can be taken as a negative, whereas a guy just made a mistake. There's also an image problem for what women are in ICT. What you have here is a shot from an open source conference. You could say that open source conferences are quite similar to NREN conferences. We're similar type of people. But this is the imagery that they think women should be at ICT. We're basically accessories to the technologies. And trust me, the consumer grade ones are even worse. The consumer grade ones are borderline pornographic. And another barrier is sometimes we're just invisible. We make the suggestions, but they're not heard unless we have this nice little echo. So this is basically why there's barriers to women in ICT. But I've been in NRENs for a long time, and I don't think that at our heart we are really like that. There has never been booth babes at TNC. I don't think there will ever be booth babes at TNC. This slide here is just a fraction of the women that I've worked with in the NREN community over time. The ones I could get photos for very quickly. So if you're not on this slide, don't worry. It covers everybody from pioneering mathematics professors through to PhD students working on the leading edge of identity technology. It's got security people, network engineers, it's got business development people, it's got everybody. But sometimes we don't quite make the most out of this as we should. Now, some of you may remember in TNC in Prague, there was a presentation on the future of NRENs. And some of you may notice there's a bit of a diversity issue on this panel. And you might be saying, no, wait, there's a woman. Well, Anna Preston, as she was then, is that woman. And she was the moderator, not giving the individual talks. And that's a role that forces you not to give your opinion. But she did, and she called out the lack of diversity on this panel. So it's terribly easy, even when we do a lot of things right, to accidentally do it wrong. Now, where am I going with this? Well, first of all, I'm going to tell you where I'm not going with this. None of the women that you saw on that slide earlier are token anything. They're your peers, and we've worked up together with you. So we are not token anything. And also, you don't need a woman necessarily to just know what women's rights are. One woman cannot represent every single woman. But we do need to do something to engineer equality true. Fair is not exactly the same as everybody being treated the same. Fair is making sure that everybody gets what they need to succeed. And if you've got subconscious bias in front of you, you need maybe a little bit more assistance to succeed. I would not be standing here to talk to you were it not from that assistance from several people. I'm not going to go through them all, but people like Dave Wilson in HEANet, people like Christoph Witzig in Switch have gotten me here, people like Aphrodite Savasti. And what I want to do is make sure that those opportunities are open to any women in Géant, in the wider NREN community right now, and who may come into us. We need to engineer equality true. This is a call to both men and women, by the way. I noticed a lot of the men left during the panel earlier. You're in this too. So if you're interested in doing more and becoming more active, find me on Twitter, email, or somewhere near the Géant stand all this week. Thank you very much.
Clearly it's not a Swiss timepiece. They make watches now, but I'm allowed to stop it, right? That's the liberty that Guido and I have. We've given some people extra time because we like them. More than likely. So we've got 7 minutes now, and we've got Ken. So please remember that we do have an opening reception. Starts at 8 o'clock.
Are you ad-libbing this?
Yeah.
All right, yeah.
Well, you'll definitely be out of here by the gala dinner on Wednesday. But Ken has been known
For a long time.
a long time. He's got a lot to talk about. And he's... If we tick down the clock a couple more minutes, we're getting closer and closer to his maximum time limit. So he needs to come up here and either start talking for us to stop. But I'd like to thank, because I might not have an opportunity before the stream shuts down and the Nordernet guys go home, to thank all of the speakers that we've had for this session. I think they've all done a great job, Ken included. It was good to see that the auditorium started to fill up after people had their fill of coffee. And the lightning talks keep getting better and better. And it's actually much harder every year to select the people that will fill this program, because we get more and more great talks. And Guido and I have the unfortunate job of telling some people, sorry, not this year. And
Sorry, we haven't been allowed to take over TNC Holers Bowlers yet.
Yeah, we could probably just have the whole program as 5-minute talks, but sometimes you need in-depth information as well as taster information.
The longer we speak, eventually an equal opportunity will kick us off stage. Come on, Nicole, do it. Nicole.
Damn. We're looking for replacements.
We're looking for understudies, absolutely.
Here's Ken.
Thanks, guys. Thanks, everybody. I want to thank Internet, too, and I want to thank the NIST NSTIC program that has funded some of this work, and I want to thank colleagues old and new for their contributions. I also want to mention that consent was part of the original vision. I was there in the room when we first started Federated Identity. This is the last element of that original vision for us to tackle. It's a very important piece. It's not easy. We're working on it right now. I would point out that consent is going to be tricky stuff, and so we should look for alternatives to consent wherever possible. But that said, we do need to put these capabilities into the hands of the users. Depending on the country you're in, your consent mileage may vary. And internationally, the situation is highly tangled as well. One of the things that this work has uncovered is the internal consent marketplace. So we tend to think of consent as going between an IDP and an SP far away. At major universities in the US, there are 1,500 student applications interacting with each other. Basketball ticket sharing, ride sharing, students writing stuff, throwing it into the marketplace, needing to know other students' schedules, and releasing that information to know what time to pick you up for the game. In large universities in the US, there's a lot of departments that are writing their own applications and need access to central data, and often they need to shop for attributes. At the University of Washington, this is part of the menu that an application can look at to ask for attributes, and then it's going to need consent of the user because it's not the central IT organization asking for the attributes. It's a student application, it's a departmental application, it needs consent. So these internal use cases were not on our radar before. We think they're widespread now, yet another place where we have to do consent. I would point out that the international consent cases are tough. In the US, we have particular problems because the deciders, as they're called, are outside of central IT. I want to acknowledge that some federations have stepped up to the bar. The Swiss, the Irish Federation and the Australian federations have all built infrastructure to nurture consent. We may need to do the same in other federations. Hub and spokes do this as well. I'm not going to go through this list, but this is anchored in research on human subjects by some of the best experts in the world at Carnegie Mellon University about what is it that's going to determine good consent. In particular, notice that additional detail. That's the informed in informed consent. Research has established it's those 4 characteristics of attribute release that users are most concerned about. We may need to make sure that they have access to answers for that in order to do their consent. Because consent management is going to be painful, users will want to suppress consent going forward. We're going to need tools so I get an SMS message that something has been released or some other notification. My informed consent may not be based upon structured information. I want to know what my friends released to this website. Can I do reputation systems for informed consent? We're just at the beginning of understanding this space. One of the other things the research shows is that we need to make sure that the actions are positive or negative, not continue, the way certain large vendors suggest when we do click-throughs. In fact, all of the issues around users ignoring prompts, we have a chance right now, as we roll out consent, to not make those mistakes. Wouldn't it be nice? One of the other reasons that we're doing this is for identity portability. It may well be the case that you have 1,000 release policies when this is all said and done. You want to change your IDP. How do you move that? So we've developed software. Here's the screens associated with it. You can see toggling buttons. I have a reputation to maintain, but I'm going to run through all this stuff. I will mention it's very hard to find applications that are actually privacy preserving, that expect minimum attribute release. This is the infrastructure we're building for this. I want to thank some other folks for writing some code that's going to be useful for this. Key functions, lessons learned. It's full motion JPEG. Thank you.
Yay! But you'll all be able to find all of the speakers at the opening reception tonight. Hey, we've made some glasses. eBay? No? So, what else do we have to tell people? Where's the piece of paper, Guido? Because I've now lost it. There's some important stuff. Check the website for more information. There's notifications, opening reception, feedback, fill in your feedback forms, check the sessions, Check the sessions, there's BOFs, demonstrations and the posters, as we've already said. And what else? And it's way too early to tell you about Wednesday night's gala dinner. So thank you all, and there's plenty of things to do around the building and Porto. Enjoy your time at TNC, and we'll see you later. Yeah.